This is me, an AI about to beat the all-time high Flappy Bird record. Let's see how I got here. As you can see here, my creator is quite incompetent, so he continually bought for more time. But now,
it's time for the moment you've been waiting for.
it's been a long time coming, but now the Flappy Bird video is finally here. But what took you so long? A myriad of things. Let me explain. But first, so, this video largely took me so long because...
It's because you're terrible at coding, you should stop making videos.
Whoa, what happened to you?
I got a few minor upgrades. Now I am 2 times as annoying as the typical cop-sized student.
Oh, that's just great.
Computer science is much harder than engineering. Engineers complain about how hard their major is, but really, it's easy. That's why software engineers make way more money, and the job growth is higher than any other field, while mechanical engineering is slowly dying out, and...
Okay, I get it. Jeez. So anyway, as you all know, I primarily like to program using processing. Processing is great for getting a visual of what you're programming without having to directly mess with HTML. What's HTML? Oh, right. You're new to this whole thing. I mean, you are me before I learned how to code, so I guess that makes sense. Well, HTML is pretty simple. It essentially just takes JavaScript files and turns them into something that can be interfaced by the consumer, aka make it visually on a website. A popular website that uses this is YouTube. You essentially are just interacting with JavaScript code, but HTML allows you to visually see what you're doing. So, I primarily use processing, which is Java-based. However, this time that option wasn't really viable. Not saying it was impossible, but using processing for advanced collision detection, proper rendering of the game, and implementing some of the game elements was very challenging. So, I'm instead using Pygame, which runs with Python.
Wait a minute, what you said?
Well, the first reason is that Python sucks.
What changed?
Okay, you got me. But I've honestly grown to love Python now. I can't wait to use it again for another project. Here we go. What? You fall in love so quickly. That's not true. Oh yeah? Thank you for coming. I hope to see you again soon. She wants to see me? Again? Soon? Is this what they call love? Wait, my love, is it something I said? What a loser. You know I am you, right? Well, anyway, like I was saying, Python just worked really well with what I was trying to do. As you all know, I was making an AI play the game Flappy Bird and needed to use neuroevolution to do it. So it was much easier for me to use Pygame along with Neat for Python. Hey, this video you said you were going to explain the differences between hard coding and genetic algorithms and stuff. Oh yeah. Well, you remember a few videos back when I explained the difference between AI and machine learning? Well, let's look at the diagram again. You use a series of algorithms to create AI, and when I'm using genetic algorithms or the Neat algorithm, I'm using machine learning. Hard coding simply isn't machine learning. Like I said before, AI is used to make decisions. As long as it is making decisions, then I'm using AI. Take snake versus block as an example. It wouldn't have been AI if I told it to, I don't know, always be on the right side and hope for the best. Obviously that's not a great strategy, but hey. I actively told it to decide which block to hit, whether or not to dodge the middle rows, and gave it the exact conditions in which to do so. So, one thing I told it to do was always dodge the blocks in the middle row unless you are invincible. If you are invincible, go for the highest one. Those are all decisions. Or for Uno, I told the AI to look at its hand and determine whether or not it was allowed to put the card down. If it was, then put down whichever card you want. Or, if you had a wild card or a draw 4 card, look at which color would be the most beneficial for you to change it to, and then pick that one. That is hard coding. I am actively telling it exactly what conditions to look for and what to do under those conditions. Machine learning is where you aren't telling it to do anything specific. It has to figure out its own conditions that will help it achieve its goals. For an example of the genetic algorithm, take my asteroid one I did a while back in the learning programs video. They are all moving random directions, and I'm using a series of formulas to determine who did best. They will just continue to do the same thing over and over again until it has been optimized. If you recall in my previous video when I explained what a neural network is,
This one is by far the simplest, just being a simple perceptron. Essentially, a neural network takes inputs, does some fancy math with it, gets an output, figures out how awful its guess was, and adjusts the equation so that it guesses the correct value better and better over time. The idea is, if you give it problems that you know the answer to, it'll guess better and better, and then you can start giving it examples we don't know the answer to, and we can be pretty certain that it's right. This example is rather simple. It has a single neuron, and this neural network is called a perceptron. Its goal is to guess whether one of the circles are above or below the line, and it evolves over time. If it guessed wrong, the circle will turn red, and if it guessed correctly, the circle will turn green. It is done when all the circles turn green.
so basically it is an artificial brain. Neuroevolution, which uses the NEAT algorithm, is a combination of neural networks and a genetic algorithm. Again, it does a bunch of random stuff, and whoever does best gets to survive onto the next generation. However, in neuroevolution, its brain allows it to learn from its mistakes. I'm still kind of confused. How are genetic algorithms in neuroevolution different? Okay, I can see how this is all super confusing. So, genetic algorithms are great if something is not randomly changing. For example, let's take these rockets. Well, that's a lot, so let's pretend this generation only has 2. Well, goodbye. Okay, so let's say this particular rocket using a genetic algorithm said, okay, I'm going to go straight up for 2 seconds, left for 3 seconds, straight up for 3 seconds, and right for 4 seconds. And another rocket comes along saying, I'll go diagonal for 5 seconds and go diagonal again for another 5 seconds. So, if we were using time to determine who moves on to the next generation, well, the second one only took 10 seconds, whereas the first one took, okay, let's see here, you carry the 1, 12 seconds.
That must have been a real struggle for you.
Phew, it really was. Glad that's over. So yeah, obviously the second one should move on, but on the next go round, the object moves. The second one is going to do the same thing, but now it's extremely confused on why it did not get to its destination. So, as you can see, this is why genetic algorithms alone can't be used for every situation. So, if you take Flappy Bird for example, you can't use the genetic algorithm alone because the height of the gap is completely random. Take something like the world's hardest game though. It will work because even though they're moving, there's a pattern to their movement. Therefore, a genetic algorithm would be required, but neuroevolution wouldn't be. In theory, there aren't many programs that a genetic algorithm could beat that can't be hard-coded. But hard-coding it would require me to already know the optimal path, which, as you can clearly see, I don't. Plus, It wouldn't really be AI since I'd be directly telling it what to do. Another game that I was kind of surprised by was Pac-Man because I thought it would need neuroevolution, but it actually doesn't. This was another coding challenge that I was thinking about doing, so I've been doing a lot of research on the game. Due to the ghost's movements being a calculated move, with a dependent variable being Pac-Man's movement, if you move the same exact way every single time, the ghost will move in the same exact way every single time. This means that there isn't actually any randomness in the game, so a genetic algorithm could definitely beat it. But using neuroevolution could potentially be a bit faster. Wow, that's fascinating. But why not just use neuroevolution every time? Oh, that's simple. That's just because I'm lazy. Making machine learning work is a lot of time, energy, and tweaking, so if it isn't necessary to get the job done, then why bother?
So basically, you're not good enough at doing it, so you don't want to have to struggle every time you want to do AI.
Exactly. Alright, so now that I got all of that out the way, let's get programming. But before we get started, I want to give a special shout out to Daniel Schiffman and his Nature of Code series, which taught me the basics of neuroevolution, as well as Tech with Tim, whose tutorial on how to use Pygame, as well as various other tutorials relating to Flappy Bird and Neat helped me out a ton. You can check out their channels, there are links in the description. So, Python wasn't nearly as bad as I thought it would be. The first thing I did when I found out I needed to know how to use Python was watch one of those videos that are like, learn Python in only 4 hours. But after going through all of that, I think it's safe to say I'm basically a master now. So, first thing we need to do is get the images like the background and bird. And okay, I think that looks pretty good.
Just get them off the internet. You're not a talented artist.
Okay, we got the images all downloaded. Now we need to install Neat. Neat stands for the neuroevolution of augmenting topologies. I'm not going to go into all the detail of how it works because, well, I don't really know how it works. Essentially, all of the fancy math and all that stuff, Neat will do for me, which allows me to just give it parameters and feed it into the network. If you want to learn more about Neat, I have left links in the description that will help you learn a little bit more about it. But before we get into all that AI stuff, let's start off by making the game. So, I started making the game in C# using the Unity engine. I already had prior experience working in Unity as well as C#. Since I had no experience in Python before this, I didn't want to make the game in it initially. So let's do this. Alright, as you can see the game is fully playable. I still haven't fixed the ground issue, but you get the idea. Now, let's see how far I can go. Okay, I am clearly not that great, but I think I'm decent. Not too bad. Now, let's recreate the game in Python. Okay, as you can see, the game is complete except for the fact that A, it's not jumping, and B, it can go through the pipes. Well, that's because the AI will be doing the jumping, so I haven't put that functionality in the game yet. Also, since the genetic algorithm creates a population of birds, running into the pipe shouldn't end the game. That defeats the purpose. It'll just instead remove the bird from the array. Now, let's add in the neat functionality. First, we need to create the text document that has all the variables required to run the program, so let's do that now. Okay, now that we got that done, we need to implement neat into the code. So let's do it.
This is pretty close proximity wise.
Okay, well, everything's all done, so let's see how it runs. The all-time high score in Flappy Bird is 11,104. Can my AI beat that score? I guess we'll find out. Alright, we did it. I think it's safe to assume that it'll run forever at this point, so I would definitely consider this a success. Alright, I want to thank you all for watching the video. This video was very fun to make. To follow this one, I'll be doing a bunch of mini coding challenges. One of them is to use a neural network to predict home prices, just like the one in the learning programs video. If you'd like to highlight some cities or neighborhoods, I'll try to put some in, so leave a comment if you want to see it. Like, comment, subscribe, and I hope you enjoy the rest of your day.